Hi Sophie, I wanted to go over some mathematical induction problem that we looked at yesterday. Now, mathematical induction, you're just trying to prove that some sequence or series is equal to a formula. So for this is saying that if we add up all the numbers of this pattern, notice the pattern is the sequence number plus 2. So for example, this is the first number in the sequence, so its value is 1 plus 2. This is the second number in the sequence, so its value is 2 plus 2, which is 4. So if we wanted to know the value of the 10th number in the sequence, it would be 10 plus 2, which is 12. Now what this formula does is it adds up all of those numbers in the sequence. Okay, so for example, we said the 10th number in the sequence was going to be 10 plus 2, which is 12. Okay, so then if we added up those first 12 numbers, it would be, remember it's the 10th number in the sequence, so it would be 10 divided by 2, which is 5, and then 10 plus 5, which is 15. So we would get, if we added up the first 10 numbers in the sequence, it would be 75. Okay, so that's the idea behind what this formula does. Okay, now in mathematical induction, you're just trying to prove that this formula works. Okay, it's kind of a very formal mathematical proof. So this is what mathematicians do for a living, is they just kind of prove that things work. Okay, so what you're going to do is you're going to have this idea of S sub k and S sub k sub 1. All right, so with S sub k, you're basically substituting k into your formula. So we'd have k over 2 times k plus 5. All right, now we're gonna add something to this, but I'm gonna leave that blank for the moment. Just put a big box here. Okay, over here we're gonna substitute. We're gonna say what's the sum of the next number in the sequence. So everywhere we have n, you're gonna substitute k plus 1. Okay, so you're gonna have k plus 1 over 2 times, again, we're gonna substitute k plus 1 plus 5. Pardon me, I'm drawing with a mouse. I'm not very good with that. Okay, so you're trying to see if this is equal to that. It's kind of like an identity where you're trying to get the left-hand side to match the right-hand side. All right, now remember, this was the sum for the next number in the sequence. This was the sum for the previous number. So we have to add to this the next number in the sequence, which according to the rule means you add 2 to the sequence number. Okay, so the next number in the sequence would be, remember, next number is k plus 1. And we're going to add 2 to that. Okay, so insert k into your rule, and then add, then you have to basically use the rule to find the next number in the sequence. You're adding the next number in the sequence, and then we're saying that's equal to the rule if we substitute k plus 1. All right. Again, it's a mathematical proof. It takes a little bit getting used to. All right. Think about, you've got your rule with k in it, your rule with k plus 1, but with this one you have to add the next number in the sequence. Okay. Now all you're trying to do is you're going to do the algebra here to get this side to match that side. And I'm going to kind of leave that up to you to make sure these match. But basically the idea is you're going to distribute. You're going to get k squared plus 5k all over 2, plus this becomes a k plus 3. This, realize, this becomes a k plus 1 over 2 times, and then just create this, add the like terms, and this becomes a k plus 6 over 1. Multiply your two binomials. Again, you're going to work this down so that your left-hand side matches your right-hand side. So you've done a mathematical proof by mathematical induction. I hope this helps. Like I said, this is some of the harder stuff for the year. So you've got a couple examples from your teacher, and then see if you can work this one all the way through. Great. Good luck with that.